Hello everyone, in this little video we will review how to use a critical value table to basically tell when a product like this is positive or negative. For this case here, in this inequality, you see, we want the values of x for which minus 2x plus 1 bracket x minus 4 is positive. The idea is to use the rules of sign for multiplication. If you multiply two positive numbers, the result will be positive. If you multiply two negative numbers, it's the same thing. And if one is positive, one is negative, the product is going to be negative. Okay, that's quite simple. So we need actually to tell when each one of these two factors is going to be 0. You see that for the first one, if you solve minus 2x plus 1 is equal to 0, x is going to be 1/2. And for the second one, if you solve x minus 4 is 0, you'll find that x equals to 4. So these two values here of 1/2 and 4 are the values at which these factors change sign. Let's represent this in a diagram that is called a critical value table. In the first row of our critical value table, we will write the important values of x. For us, in this example, it's 1/2 and 4. Below that, we'll write two rows with each one of the two factors, and then in the last row, we have the product of these two factors. So we know that for x is 1/2, right here, the first factor here is equal to 0. And we know that when x is 4, this second factor here is equal to 0. We now need to look at the sign of these two factors when x is less than 1/2, or when x is in between 1/2 and 4, or when x is greater than 4. If you look at this one here, this is the equation of a line with gradient minus 2. So your line is going down. If your line is going down and is 0 at 1/2, it means that you can basically quickly sketch a graph like this. Here is your line, here is 1/2. You see that the values of minus 2x plus 1 is positive before that and negative after that. It's basically because the gradient is negative and that your line is going down. So we can write that this factor was positive when x was less than 1/2, so right here, and then becomes negative when x is greater than 1/2, just like it's shown here. For the second factor, you see that the gradient is 1, so the line is going up. So these values were actually negative before you reach 0 and positive after that. And you can check this if you quickly sketch the graph of a line with a positive gradient. If here it's 0, it was negative before and positive after. So let's now use this to tell what is the sign of the product here. So when x is less than 1/2, you're multiplying a positive number with a negative number, so this makes the product negative. Here the product is going to be 0, just like there. When x is in between 1/2 and 4, you know that minus 2x plus 1 is going to be negative, that x minus 4 is going to be negative. So you're multiplying two negative factors, making the product positive. And finally, when x is greater than 4 here, you're multiplying a negative factor with a positive one, which makes a negative product. We can now solve the inequality. Remember, we want the product to be strictly positive, so it's right there that we're looking for the values of x. So you can write that 1/2 has to be less than x, which has to be less than 4. If you are familiar with quadratics, you could have seen that if we expand this product, we'll get a quadratic expression for which the coefficient of x squared is going to be this minus 2. So this means that if we plot this graph, we have a parabola facing down like this, okay, with two roots here and there. And because this parabola is facing down, you can say that the value of the quadratic expression was negative, and then positive, and then negative, which matches completely the result that we have in the critical value table. Let's now have a look at a more complex example where the inequality has a degree higher than 2. So let's try to now solve minus x cubed minus 2x squared plus 3x is positive. To do so using the critical value table, we need to express this expression here as a product of factors. One important thing to notice when you try and factorize this expression is the fact that x is a common factor to these three terms. Because the coefficient of x cubed here is minus 1, it might even be a good idea to factorize by minus x. So we have minus x brackets x squared plus 2x minus 3 is positive. To further factorize this expression, we need to find two numbers who multiply to minus 3 and add up to plus 2. These two numbers are going to be plus 3 and minus 1. So we get minus x brackets x plus 3 brackets x minus 1 is positive. So you see that now we factorize the expression and we get three different factors. Each of these factors is going to give us a critical value. So this critical value is obviously going to be 0. The second one, x plus 3, is going to be 0 when x is minus 3. And this one is going to be 0 when x is 1. So let's draw the critical value table. To draw this table, we first ordered the three critical value in increasing order, and we've arranged here in the first column the three different factors for our expression. So let's first deal with the first factor minus x. This factor is 0 when x is 0, obviously. You see that here the gradient of this linear expression is a minus 1. This means that your graph is going down, so it was positive before you reach 0 and negative after that. For the second factor x plus 3, it's 0 when x is minus 3. Because the gradient is now positive, the gradient is 1. You can say that before you reach 0 it was negative, and then it was positive after that. For the last one, the critical value is 1, so it was 0 here, and you get something negative before and positive after. Let's now apply the rule of signs for multiplication. If you multiply these three numbers together, you'll have one positive and two negative, so in the end your product is going to be positive. 0 here, negative, 0. The third one is going to be 2 negative again and a positive, so it's going to be positive, and the last one is going to be negative. So there we are, we've completed the critical value table. We need to give the values of x for which this expression here is strictly positive. So this means that x needs to be less than minus 3, or in between 0 and 1 to be positive. So we can write this as x has to be less than minus 3, or 0 is less than x, which is less than 1. So that's the end of this video on critical value tables. I hope it helped, and see you in the next video.